Uh, Good afternoon. Amanda Karpaev, yeah?
Yeah, hello. Yes, I'm ready. Should I share my screen?
What's the ID of your
My ID is 423.
423. Okay, then.
Let me share my screen. 1 second.
Yeah. You can.
So sharing. So share the screen. To grant access. Okay, 1 second. I need to grant access to this app to access my screen. 1 second. Yes, sorry. Use password used. Okay. So it asks me to quit the app and enter again because. Okay. Can I quit and reopen?
Okay, then. Okay.
Okay. 1 second.
Okay, that's it.
So I'm sorry that I had to allow my screen Zoom app to share my screen. Sorry. So I try again. 1 second. So the share desktop. Okay. You screen sharing. Okay. To bypass system settings, access your screen. Allow. Okay. I hope it's working.
Yeah, we can see.
So can you see my screen?
Yes. Yeah.
Sure. Then that's our presentation, and as you see,
We can see. We can see. You can start.
Okay. So our paper ID is 423, as you see, and our authors Azat Aldeshev, Sanjar Saidbekov, Amanda Karpaev, Parasat Inspekov, Oljas Dairov, and Nurjan Momankul. So we are presenting the topic harmonizing emotions and music with fuzzy intelligence for personalized recommendations. So basically, in this research, we aim to develop emotion-based music recommendation system, which uses fuzzy logics to address some subjective nature of human emotions. So based on this subjective nature of the emotions, we basically can measure, or we can guess which kind of music this person likes, and it kind of improves the music perception. So the system integrates emotion-based features and intelligent classification models to generate this personalized music recommendation system. And so we have a few primary objectives of this research. As you see, it's classifying music emotions by employing this fuzzy-nearest mean. That's a type of classifier which allows for tracking emotion variations of the song. And to recognize these facial emotions, we use fuzzy inference system. So we kind of capture the real-time emotional states. And also we adapt this Russell's circumplex model of emotions for mapping emotions based on some kind of valence dimensions. Yeah. So also we kind of evaluate and use all this system based on specific data set. It's a Redboot Faces database, which helps us to assess this accuracy, adaptability, and user satisfaction. So to improve this engagement in terms of context and to make it relevant to real-time emotion of the person, so we basically build this real-time emotion-aware music recommendation system. So that's our primary objectives. Then we move to some theory. So we use this Russell circumplex model of emotions. As you see, we have few categories like arousal, neutral state, valence. When we activate emotions negatively or positively. Also, we have this intensity level, as you see, and like excited, tense, angry, happy, relaxed, calm, exhausted, and many other. What else? So what is exactly Redboat Faces database? It's a data set which uses few personal information across age, gender, ethnicity, and the outputs of the both components are integrated to generate personalized playlists, mapping this emotion states to corresponding music tracks, as you see. And we have emotion classes like angry, and we have a few classes, as you see, about 4,259. Yeah, and this, so we totally have 37,075 classes, which like a lot in terms of classes related to emotions. Yeah, so we cannot say it's all of them can be used. So we had to do some pre-processing. So we had to kind of improve this framework in terms of accuracy, in terms of relevance. And so we did some kind of pre-processing of this data set. And then we moved to the next one, which is a music emotion classification performed by according to this scheme, as you see, and this diagram, which as you see has this face detection, facial features extraction, membership functions, few membership functions, which basically some kind of parameter tuning algorithms, yeah, facial features and extracted features. So all of them as a single system should help us to employ the features from dataset to get to build these fuzzy vectors. So you see words like feature preprocessing, fuzzy vector assignment, final classification. So it kind of helps us to assign all these small features to certain kind of vectors. And so we basically do some kind of conversion, yeah? So we do some kind of embedding. And this embedding helps us to convert it to the digital format and helps us to process further to get better understanding so we basically try to express all emotions as a numbers, yeah. So and further we do some calculations or computing, and this helps us to finally do some kind of emotion inference, like which one is anger, which one is fear, which one is like happiness, and this kind of classifier helps us to reach some kind of decision about the current state of the person. So person basically can be not like overhyped, or can be not like too much, I don't know, optimistic right now, but by having all these faces, how to say, face expressions, we try to match everything. So it's not like direct matching, like this kind of face matches to this kind of music. We try to match some patterns which previously in previous steps were converted to the digital format, yeah? So so we have, okay, you see this app interface. So it's like our most simple app interface, which kind of used to just for how it should work. Yeah, but indeed, if we try to use this model in more complex apps, we have to improve the so we have more parameters when actually we presenting. So this interface just presents like half of the parameters we can use from the model. So and this kind of just a very simple interface how could work. And we could upload image. Also, we can do some photo. Also, we can select a music track for image, like some kind of music, and it detects this emotion, and so it gives us like a recommended playlist. Of course, we use some standard playlist from some kind of Yandex Music, for example, yeah. But actually, we can generate this playlist right on place. Yeah, we can generate all this music online, and this music can exactly match the mood of the person. Yeah. So this so basically this playlists are from were composed by artists, but also we can generate this playlist from scratch. Yeah. So we can just not only playlists, we can generate songs, we can generate actually sound, audio, everything. Yeah, so to match or to satisfy the person's needs, and it kind of gives the relaxation. It kind of gives relaxation. Also gives the how to say, gives relaxation. It gives relief. Yeah, gives a relief to the person. So so you see our results. As you see, we have mean square error. We have mean square error root, and you see manual annotated. Okay, we had a manual annotated part of the data. It's like more like data augmentation. Yeah, it's not for like for just. It's not just new data set. It's a like augmentation of existing data sets. We have also another concurrent data set like MRP, which is also a good data set, but we mostly our research based on this RFD, and MRP kind of gives us I don't know, some kind of benchmark kind of data set, helps us to compare, do some kind of comparative study. Yeah, so just for comparison. So I think our students, our master students, which basically did all this job, all this research, they kind of could match the benchmark results. Not like a really good one, but in this case, it's good one. Okay, we just show the best results. But in my perspective as a supervisor of the students, I think it's good. Yeah, so we maybe it can be used in industrial scale. So we could use in real players or real music players and so on. So and confusion matrix also matches all these results, of course. Okay, what else? So as a conclusion, what I can say. So this study presents this novel emotion-based music recommendation system, which generates personalized playlists. As I said, this personalized playlist is only an example or like exemplary playlists. Actually, we can generate if we do further research, we can in future we can generate exact audio, we can generate exact sound and music for certain person. Yeah, so by integrating this music emotion classification and facial emotion recognition, of course this all this research is based on previous standards kind of models, but we kind of try to make it more, I don't know, more like personalized. Yeah, so we try to make it more tied to the certain kind of person. So we actually for future work, we will explore multimodal emotion recognition. So we try to deepen all this research towards some kind of better personalization, and integrating additional psychological signals such as a heart rate variability, electrodermal activity to further refine the system's emotional sensitivity, and expanding its dataset quality, optimizing computational efficiency. And this is areas which we focus to improve. And this research contributes to growing intersection of artificial intelligence, digital signal processing, effective computing, opening perspectives for future innovations in personalized music algorithms. As you see, this is just only the most important ones, yeah, but we can go further. We can go in terms of getting more features, more personalized, I don't know, psychological signals. We can go, we can use not only heart rate, we can use some kind of, I don't know, more, so we can add more sensors. Yeah, so that's our future work, and I hope you like it. If you have any questions, please ask me.
Thank you very much for very expressive and interesting presentation. So, is this research a part of grant funding, or maybe it's your own research by your own interest without any funding?
Actually, it's not funded by any institution, but it's the whole research is done by our master students in Kazakh British Technical University. So we actually I supervise like 20 master students, and I have a lot of research done, and not all of them are published, and it's just one of them which kind of we could publish and we could submit to this conference, but we have a lot of ideas, and so and maybe in future we also try to submit to the grant programs, where we have a lot of grant programs. So it's very applied and practical research. Yeah, so we also not only about research grants, we can apply to, I don't know, or we can propose to startups, we can propose to various companies to use this model. And right now we very much intended, or we much tended to go towards maybe industry level application.
Yeah. It's very promising, and it's very relevant to practical needs. So, any questions, please? Muslim Zaksylikovich, do you have?
No, only to admit such good presentation and very actual direction of practical approach. I admire this.
Thank you. Thank you very much.
Thank you very much. So, if we have no question, we say goodbye for you, Amandik.
Oh, thank you. Thank you. See you. Thank you. Thank you very much.
Best wishes.
Thank you.
Muslim Zaksylikovich,
Да.
any participants maybe in...
We concluded for today's scheduled plan, and until lunchtime, we completed all planned scheduled presentations for today. Only this presentation was remaining, but Amandik, thank you.
I'm so sorry. I just watched this. I'm sorry. I just looked at this program, and I thought this was after the lunch break. So only because I joined this 2:30 p.m. This was so maybe of course I had time before, so it's just a matter of this.
No problem. Maybe there was some misunderstanding. Yeah. Okay.
Yeah. Sure. It's some kind of misunderstanding. Sure. Thank you.
Okay, then by 5 o'clock it's going to be closing ceremony. 5 o'clock online.
Mhm.
Of course, I
Now-
joined. Thank you.
Then we're
Yes.
completing our sections presentations, and thank you very much for participation. See you in next
Mhm.
conferences. Thank you. Goodbye.
See you. Bye bye. Bye bye.
Goodbye.